Everybody say hi, Michael, Riley, and Reese.
Hi, Michael.
I'm stuck in concrete.
Anyway. All right. So we've started section 3.7 notes, and this is quadratic inequalities, and we started by saying that inequalities means not equal. All right, here we are. What is it if it's not equal? Okay, we're done. We're done. What is it if it's not equal? It is what? It is unequal. What is it if it's not equal? Isaac Mackin, do you need moved?
No.
Okay, then shush. That means not equal. What do we call? What do we use if it's not equal? We don't use an equal sign. We use
inequality sign.
What is an inequality sign? Yeah.
Than, equal to, or less than. Or
there you go. These are what we need. We need greater than, less than, greater than or equal to, less than or equal to. If it is a greater than symbol, we use a dotted line. If it's a less than symbol, we use a dotted line. If it's a greater than or equal to symbol, we use a solid line. And if it's a less than or equal to symbol, we use a solid line. And this is what tells me, this little mark down below, if it's equal to, then we use a solid line. If it's not equal to or just greater than, less than, we use a dotted line. Okay, we've done these before. And we've done like the shading thing, but we never done it with quadratics, okay? So same thing again, we're just doing quadratics with it, all right? Let's go down here, and we're graphing quadratics, or we're graphing parabolas, and then it just says shade accordingly. So nothing different from what we've been doing already, it's just shading accordingly afterward, all right? Shading accordingly, all right? Let's go down to the first example. Are we ready to go? They do not tell us how to graph this thing. So we're just going to use some information that we know from parabolas. That's these guys. We're going to graph this thing. So one of the things that we could do is we could find the y-intercept really easily. And we're going to do that. Okay. Another thing that we could find is the, let's say the vertex. Okay. Axis of symmetry. I'm going to do, let's do axis of symmetry. So we'll do axis of symmetry. I'm going to make him a small box. And then we have the x-intercept. So we've got all of these things. And we don't necessarily need to do all of these things for every single problem, because sometimes we just do two of them and it gives me enough points that I can go ahead and graph the thing. And that's fine. One other thing I'm going to put off to the side over here is up or down. Do you know what I'm talking about?
It's up.
Okay. So up or down. So those 5 questions, we can answer, a couple of them and get the graph of what this thing looks like and then just graph them. Okay. So let's do that first. Let's talk about this function right here, x squared plus 2x plus 1. He opens, which way did you say, Romeo? Up. How do you know it's up? Because he's positive x squared, right? Positive x squared, that means he opens up. Okay. So we've got a smiley face and not a frowny face. The y-intercept. Do you guys know that that is a positive 1? It's this guy right here. The y-intercept is just that number, right? Or you're plugging 0 in for x. Okay, so the y-intercept is 1. How do you find the vertex?
Negative b over 2a.
Negative b over 2a. Okay, so let's do negative 2 over 2 times, what's the a?
1.
1, okay. 2 times 1 is 2, and what's negative 2 divided by 2? Negative 1. All right, so we've got negative 1 comma something. How do I figure out what this something is? Plug it in. So negative 1 squared plus 2 times negative 1 plus 1. Am I going too fast?
No.
No? It ends up being 0 if you do all that. Okay? All right, so we've got negative 1, 0. That's my vertex. Okay? Are we doing okay so far?
Yes.
Okay, let's graph what we have so far, and let's see what we have here, okay? So the y-intercept is at 1. The x, it's opening up. The vertex is at negative 1, 0. That's where he is, okay? Now, we've got those 2 points. And I'm going to put my axis of symmetry. And we know the axis of symmetry goes through the vertex. That's what he looks like, okay? So what's my axis of symmetry?
Negative 1.
X equals negative 1. That's what he looks like, right? Okay? X equals negative 1. And then we have, I also know that there's going to be a dot over there, right? And he's going to be a parabola that looks like this, right? I haven't even done the x-intercepts, and I know that that's what he looks like, right? Haven't even done that. Except, wait.
He's also going to be dotted.
Wait. Caitlin says he's got to be a dotted line. How?
Greater than.
Shut it off. Greater than, not equal to. So he is a dotted line. So shoot.
One of my bros.
Okay. So he is a dotted line, and there's that. Are we happy so far? Good to go? We haven't even done the x-intercepts. right? And we know what he looks like already, so we could just skip the x-intercept. Would you like to do the
It's
x-intercepts?
-1.
Yeah, the x-intercepts are -1, okay? Because, if you want to write this down, x squared plus 2x plus 1. How do we find x-intercepts, by the way?
Plug in 0 for.
Plug in 0 for y, okay? And so then we have, like, we could factor, or we could use the quadratic formula, right? Those are things that we could do to find the x-intercepts, okay? Now, if we look at x squared plus 2x plus 1, he is really nice. What is he? X squared plus 2x plus 1. What is he? He's a simple trinomial, right? And is there a number I can multiply to give me 1, but when I add them, give me 2? 1 and 1, right? So x plus 1 and x plus 1, right? And if I set x plus 1 equal to 0, x equals -1, which we already have graphed right there. And x equals
-1.
also -1 again. Same thing, okay? Graphed right there. So we didn't even have to do the x-intercepts, but that's how we would if we needed that point, right? X-intercepts. We factored him down as a simple trinomial. Okay, one more thing is we have to shade. So we know he's a dotted line, but let me go back here. And this is saying y is greater than. Y is greater than. Okay, greater than usually means above. But where is he above?
Inside.
You think it's inside?
Yes.
Okay, so I have, my 6th period class was kind of a little bit confused the first time we did this, and they said, okay, is above on the inside or on the outside, okay? Here's my parabola, okay, ready? I'm going to pull those arms down kind of to flatten him out, and if I do above that time, right? If I do above, okay, it's this way, right? Now I'm going to close him back up again. He's going to be inside, right?
I was
Okay,
right.
so think about it in terms of that. If you would open that parabola up again, it's going to look like that. So this is the shaded region right here. Okay. Now, what this means is that any point that is in that shaded region would work in this equation, right? Okay. So give me a point that lives inside of here that would work.
2 -1.
Two negative ones right here.
Oh, I mean the other way around. -1.
6 -1 is right here. That's not gonna work either.
-1 2.
3.
-1, -1 2 is the best point right here. That would work.
I meant to say, but I said it the opposite way around.
-1 2. What? What else? 0 4. 0 4 is right here. That would work.
032.
0 32 would work. 1 7 I heard Carson say, which is up here somewhere, right? 1 comma 7. Any of those values that live inside that shaded region will work in this equation, and that's what we're trying to get to, right? Okay, now this one was like y is greater than, okay? That's what we had. Now, before we move on to the next one, let me ask you this question. If you have y is greater than, does that always mean you're shading inside the parabola?
No. Yes.
Yeah.
I don't know. Wait, what? No.
If you have y is greater than, does that mean you're always shading inside the parabola? That's what we did here, right? When would you be shading outside?
On a frown.
If it's a frowny face, right, y is greater than, he would be around the outside, right? So it depends on whether it's facing up or down to whether greater than is inside or outside. Does that make sense? It's not always going to be one or the other. Okay, so that's kind of how that works. That's what this is describing down below here. So I'm going to skip over that. We're going to go to the next one. Okay, example 2. Here we go. They want us to solve this thing by graphing. They went ahead and plugged 0 in for y, but we're going to put y in its spot, okay? And they have this written backwards, so if you want to, we can switch this around to be y is greater than x squared plus 2x minus 8. If it helps you to do it that way, you can totally do it that way. And let's write out our things. So I'm going to do up or down. I'm going to do, let's do the y-intercept. Let's do the vertex. Let's do the AOS. Let's do the x-intercepts. And again, on the homework assignment, you don't have to do all of these, but you do have to do enough to get you the graph, right? So I would at least always do the y-intercept because those are the easy ones, right? Okay. Is this guy going to open up or down? Up, because he's x squared, right? Positive x squared. So he's up. Up. What's the y-intercept going to be? -8. It's that number right there on the end. All right, the vertex is -b over 2a. Okay, what's the b value going to be?
2.
2. So it's -2 over 2 times.
-2 over 2.
Yep, -2 over 2 times 1, which is -2 over 2, which is,
-1.
that's another -1. We have a lot of -1s in this section, I feel like, in this notes. -1. Okay, so -1 comma something. Okay, we're going to plug the -1 back in. So we have -1 squared plus 2 times -1 minus 8. Okay?
-2 minus
This
8.
is 1 minus 2 minus 8.
-10?
but then you have to add the 1. So that's negative 9 is what I got. Negative 9, yeah?
Yeah.
1 minus 2 minus 8 is negative 9, okay? All right, so let's graph that information. We have the y-intercept is negative 8. We've got negative 1 is at negative 9. We're off the chart a little bit, okay? There's my 2 spots. Negative 1, negative 9. The y-intercept is negative 8. My axis of symmetry
9
is right there, right? Okay, so how do we label the axis of symmetry? X equals negative 1, you betcha, right? That's what he looks like. Okay, now I can also say that he has a dot right here on the other side, right? Does that make sense? Okay, and that's what he's going to look like, all right? Now, before we go ahead and draw him, let's go ahead and find the x-intercepts because these come out really nice, actually. So x squared plus 2x minus 8, we're going to plug 0 in for y, and we can either factor him, we can complete the square, we can do a quadratic formula, we can do a lot of different things. Does he factor really nicely?
Yeah.
He is a simple trinomial. Let's see. Can we multiply to get negative 8, but when we add them, give us positive 2? Will you go answer that?
Yeah.
It's now.
Positive 4, negative 2.
Positive 4, negative 2. I like it. X plus 4, x minus 2. Okay? Positive 4 and negative 2 together multiplied gives me negative 8, but 4 minus 2 is positive 2, so that works, right?
Do you mean negative 4?
But when we set them equal to 0, is that what you're thinking of, Josie? When we set them equal to 0, it will be negative 4. When we set them equal to 0, it will be positive 2, right? Does that make sense? Yeah? Yeah? Okay, so my x-intercepts are negative 4 and positive 2. So negative 4, positive 2, and now I have my parabola. But before I draw him, is he solid or dotted?
Dotted.
Dotted, because it's not equal to, right? Okay, so a dotted, dotted. Okay? Dotted. Like that, something like that, right?
Yeah.
And then we have y is, if you read this backwards, do you see where the y is located here? Whoop. Y is here, and y is on the big end of the inequality, right? So y is greater than, or if we flip it around, you could see y is greater than, okay? So y is greater than, are we going to shade inside the parabola or outside?
Inside.
Okay, again, imagine that you like flatten him out a little bit. Greater than is going to be above, and then enclose him back up again. That's going to be that shaded inside, yeah? Good? Happy with that?
Yeah.
We're going to do one more of these on the back side, and it is example 3, and then we'll skip example 4 and example 5, and we'll call it a weekend, right? Okay? So you do have a little bit of homework. Okay, it's not too bad, though, I don't think. Okay? Oh, you're killing me. Oh, dang, I know. Example 3. Up or down? You can tell that I care so much. You can tell that I'm so greatly affected. I know, that's why I'm giving you something to get your mind off of your shoes, right? You are welcome, Amit. You're welcome.
No, it wasn't my dunks.
Let's go. Vertex, label your things. Go. Shush, shush, shush.
What?
Shush.
Yeah.
These are the things. We may not need all of them, but there's that. Okay, the x-intercept, axis of symmetry, vertex, y-intercept, all that good stuff. Amit, right. Write this down. This is example 3. Okay? Is this up or down? Up, because it's positive. Okay, so up. The y-intercept is negative 5. The vertex, negative b over 2a. What's b? Negative 4 over 2 times a is 2. So negative 4 over 4, which is? Again. Negative 1. Again, negative 1, right? Yep. Again, negative 1. Negative 1. Woo! Yes, the axis of symmetry, we'll get to that. Negative 1, if we plug him in, 2 times negative 1 squared plus 4 times negative 1 minus 5. This is, hold on, no, Josie. You square the negative 1 first, right?
So 1.
Times 2, this is 2, minus 4, minus 5, so reset, negative 7. Did she say negative 7? Yes, she did. She did. Okay, let's graph those. The y-intercept is negative 5. We have negative 1, negative 7, something of that nature, right? We've got that. Your axis of symmetry, Josie said, was at negative 1, right? Okay.
Yes.
X equals negative 1 is your axis of symmetry. Okay. We also know that we have a point over here at 5, right? And that's what my parabola looks like. Okay. The x-intercepts. Let's focus on that for a second. Okay.
X plus 5 and x minus 5.
2x squared plus 4x minus 5, and we set them equal to 0. Okay? Now, this guy Can we factor him down? What would he be if we factor him down? Nah, because there's a 5 there.
Divide it. No.
What would this guy be if we factored him? Which one of the 4 methods?
Common or greatest common.
He would be a complex trinomial maybe, okay? Here's what I want you, everybody watch. Don't write this down because we're going to get to a dead end, so I don't want you writing this down yet. 2x squared plus 4x minus 5. We're going to try to get him to be a complex trinomial because that's what he looks like, right? But not everything that looks like a complex trinomial actually is. I'm going to show you why here in a second, okay? So 2 times negative 5 is negative 10. Now we need multiples of negative 10. I want to multiply to get negative 10, but when I add them, give me 4, right? Multiples of negative 10 would be 1 and 10 and 2 and 5. Which one of those will give me 4 if I add them? None. So this is not a complex trinomial, even though it kind of looks like one, right? Okay, so what do we have to do now? We can't do it that way.
Divide by 2.
We can't divide by 2 because there's a 5 there.
You could have a negative 2 by 5. What's the complete square?
We can do complete the square. Since we have quadratic formula kind of in our heads from yesterday, let's do that one. Can we do that one? Okay. All right, so negative b would be negative 4 plus and minus the square root of, what comes next? B squared. Okay, what is b squared though? What is b squared? 16 minus 4 times a times c all over 2 times a. You can commence writing if you haven't already done so. You can write this down now. Okay, let's simplify some stuff.
Does it come out good or not?
No, it's going to be a decimal no matter what. Okay. All right, this stuff inside of here, Romeo says is a positive 40, right?
Yeah.
Okay. Okay, so we have negative 4. We'll have negative 4 plus the square root of 56 over 4, and we have negative 4 minus the square root of 56 over 4. And normally we would just leave our answer like that, right? But since we're graphing this thing, we're going to go ahead and actually type that into the calculator and get out a number, right? We're going to have it spit out a number. And if I remember right, this comes out as 0.87, and this one comes out as negative 2.87, I believe. Something of that nature, right? Something like that. If we type that into our calculator, we get 0.87 and negative 2.87. There it is. Okay, good. So I'm going to graph those two. 0.87 is here. Whoop. Is here. And negative 2.87 is about there. And you see where my parabola comes out nicely? Kind of the symmetric on the other side. Okay. You want me to zoom out?
Can you send me this video too?
It's gonna be on the outside.
I can. Yeah. It's going to be, okay, so is it a solid line or a dotted line? Solid, because it's equal to, right? It's solid. And
Alright,
there's
zoom in
that.
if you need to.
Okay. And let's do this. Okay, this is saying, like, my 0 is there. Here's where the y lives, right? So y is on the little end, even though it's backwards. Like, this is a greater than symbol, but since the y is on the right side, it's like saying y is less than, right? Y is on the small end, okay? So imagine that I take these two and I bend them down this way so that he's a little bit flatter, right? Okay? Less than is going to be below, right? So now if I fold him back up, it's going to be around the outside, right? That's what Reese said. Yeah? Do we agree with that?
Yes.
We got it all figured out? Okay? So less than is around the outside. So this is not different than what we've been doing before. We've always been finding the vertex, the axis of symmetry, all that good stuff. Now we're just shading stuff, right? Okay? Good? Okay? Anything else we need to add before we close the video?
No.
All right. Oh, on your homework assignment. I don't have it. Oh, yes, I do. Right here. Okay, here's your homework assignment. If you want to listen to this, I'm just going to put this on the video before I close it out. There are problems up here where you have the graphs, and then there's problems down here where you don't have the graphs. I'm not going to make you do any of this bottom area down here, just the graphy ones. Okay? And these ones are really short. You don't have to do all of the 5 things for each one of them, just as long as you can get a graph of it. Okay? So you're gonna do 1 through 6 on this side, and then on the back side, just 1 through 3. Okay? In this bottom area, what you can do is you can use this to show your work down below here. So if you need more room to find the vertex and the axis of symmetry and that type of thing, you can use this bottom area down here. But all you have for homework is 1 through 6, this chunk with the graphs, and this guy with the graphs. Okay? So that's it. Make sense? Are we clear? We know what's going on? All right, there you go. 9 problems. That's all. Right? All right, everybody say bye, people watching this video.
My people watching this video.